Hello and welcome to Rapid C++ Development, combining Embarcadero C++ Builder with Microsoft Visual C++. Your instructor is Rob Swindell, Embarcadero MVP. This is video 0 of 10, an introduction and overview. In this video, you'll get an overview of the course, discussing why you would combine Embarcadero C++ Builder with Microsoft Visual C++. Provide an overview of what you'll learn, and you'll meet your instructor. And now, here's Rob.
This video series covers the development of Windows applications using C++ Builder for the GUI, or the graphics front end of the application, and Visual C++, the Microsoft Visual Studio product, for the back-end logic in the form of DLLs. My experience with the C++ development tools from Borland and Enprise and CodeGear, Embarcadero, goes back 30 years to the original Turbo C, probably version 2.0, but that was about 1988-89. That was actually my first exposure to the C programming language, and the primary tool used for professional development for a number of years. Started using Microsoft's C compiler probably within the early 90s. Been very involved with a lot of other embedded development environments, Unix and GNU C compilers and many others. But when it comes to Windows development, still primarily using the Microsoft and Embarcadero tool chains. My first combined project using both Visual C++ and C++ Builder was an open source internet server suite. The backend logic is very cross-platform and supported a number of Unix-like operating systems like OS/2 and Windows, of course. But yet I wanted a very nice Windows GUI on top of this very portable code. So the quickest way to get that was using C++ Builder and the backend as DLLs developed in Visual Studio, Visual C++. So that project actually remains today, and that's still in that configuration of a mixed project for Windows. The subsequent videos in this series are going to teach you what you need to know to combine Visual C++ and C++ Builder modules into a single combined project, beginning with object and library file formats and compatibility. Even an experienced developer may assume that all object files and library files are interoperable, and we're going to cover that in detail in that segment. In the subsequent segment, we're going to detail what is necessary to create a Visual C++ built DLL that is compatible with your C++ Builder application. This topic includes creating C++ Builder compatible import libraries, using C++ Builder tools like COFF2OMF, implib, and tlib to create and examine library and object files. It's going to discuss how exported DLL functions are affected by C++ name mangling and function calling conventions. In the next segment, we're going to jump into sharing data between and debugging mixed projects. That's going to include sharing string constants, dynamically allocated strings, evaluating how memory leaks could occur, or heap corruption, and how to get around those problems. Also, I'll demonstrate how to use both Microsoft and Embarcadero debuggers to debug your mixed project. In the following segment, we're going to detail how to share files between your Visual C++ compiled code and your C++ Builder code. That includes dealing with issues like multi-byte to single-byte encoding, writing data to files, evaluating function failures with the debugger, and comparing standard C file access methods with Windows-specific methods. In the next video segment, we're going to cover sharing data structures between your Visual C++ and C++ Builder projects. That includes issues such as structure alignment, which includes padding and packing, integer size issues, and how to overcome those. In the next segment, we'll detail how to dynamically link DLLs with your application. The next segment gives an example of how to create GUI applications using Visual C++ and MFC. Then we have a C++ Builder and VCL GUI application development example. And finally, in the last segment, we have a review which combines example VCL applications with example Visual C++ DLLs and goes from beginning to end creation and debugging of the application. and details issues that can arise from combining DLLs with your C++ application. Professionally, I worked for a number of years, more than a decade, for a very large chip manufacturer, developing Ethernet controllers, firmware, drivers, and application software related to the firmware and drivers. These were deployed on name brand desktops and notebooks and servers that you would probably know of. You work for a large enterprise, probably have one or had one at least at some point in time. So you had this combined Visual C, C++ Builder project deployed to that Windows install, very likely. How that project became a combined project is probably a good use case story or user experience. When I first was handed the ownership and responsibility of a firmware configuration tool for Windows, it was an MFC project developed in Visual C version 6. And it was not a great application. It was not very customizable, although different PC OEMs required customization. They wanted, certain user interface features to look differently or be enabled or disabled to have different logos and such. They basically wanted it kind of customized for their platforms. So that the way that was implemented anyway in this MFC application was actually have forked versions of the code with different resources and such. And it just was not maintainable that way. And it wasn't very easy to localize or customize. And the source code consisted mostly of boilerplate code, that would be auto-generated by the IDE, the environment, the Visual Studio environment. When you dropped a control or modified something, it would create an event. It would create a bunch of boilerplate code that you weren't expected to modify, and yet that was really the majority of the code. So maintaining that code was not very fun or feasible. So rather than rewrite all the code, I left the back end as a Visual C++ project. It was already in a DLL form, used by many other applications, including third-party applications. So really no interest in changing the tool chain for that DLL. But the front end, this GUI, I chose to write in C++ Builder. And the result was a project that was very easy to maintain. Not only did it happen quick, but it was easy to customize later as new requirements came in, add more capabilities. Dynamically changed the look and feel based on OEM requirements and registry settings. So did not need forked code, did not need separate binaries, just needed the installer for a particular OEM to set registry keys a certain way, and then it would look and feel how they wanted. And it was really very easy to do in a very object-oriented, easy drag and drop UI development environment that was provided by C++ Builder. It's a very successful project. It supported 32-bit Windows very well. At the time, Borland or Barcadero, I forget, did not have a 64-bit compiler for C++ Builder. It was 32-bit only. And for 64-bit platforms, we really needed a 64-bit binary and executable. So at some point, the company hired or assigned the task to another programmer to port my GUI, my C++ Builder GUI, back to an MFC project, with all the same capabilities and customization and everything. And he did successfully do this. It looked and felt a lot like the C++ Builder application. But the source code was 10 times the size, literally. So source code, if you're a programmer for a long time, you realize more source code is not better. Less source code is better. Digital debt actually has a cost. The more lines of code you have, the more likelihood you have for bugs. So, it wasn't a good thing that the size of the source code exploded when it went back to an MFC project, but it was a clear-cut example of what needed to be done in the two environments, source code-wise, and managing that source code, and also just the ease of configuring the forms and the controls and the look and feel and everything was much easier in the C++ environment.
Well, that's it for video 0. In this video, we learned that combining C++ Builder and Visual C++ lets you leverage the strengths for each flavor of C++. You can use C++ Builder for rapid front-end GUI development, fast and flexible database connectivity, and easier to maintain projects. You use Visual C++ if it's your organizational standard, if you have legacy code to utilize, or to take advantage of some of the source that's widely available with Visual C++. Up next, we learn all about object and library file formats and their compatibility between both Embarcadero C++ Builder and Microsoft Visual C++.